Okay, so here's part B.
Yeah.
Now what we're going to do is we're going to count arrangements of the blueberry the same. If they're the same by rotation. So that rotation that keeps the squares the same.
Yeah.
So this arrangement is the same as what arrangement?
Well, you can rotate it. You can put the blueberry. You can put the blueberry like over here.
All right, enough with the gloves. I'll just grab it, put it there. Is that what you meant?
Well, it used to be here.
Yeah.
I think it would be here actually.
Here.
Here.
Okay.
Yeah.
One over.
So then it was in this slot before, and if we can rotate the plate, we can see that it's in that spot again.
Okay.
And we can put that on every different side.
All right. So what do you think is going to happen? How many different ways are there to put the blueberry in if we count 2 ways that are the same by rotation to be the same?
Well, then probably there's probably going to be every one has a double of some sort.
So
Okay.
that would be 8.
All right. Everyone has a double, so you think there'll be 8 different ways to do it. Okay. Why don't you see? See how many ways are the same as this one?
Well, you can actually rotate this one
4 more
4
times.
times.
Ooh, interesting.
So this one is counted 4 times. It look like all the edges are counted. All the edges, at least, are counted 4 times.
Oh, they're all counted 4 times on the edges. Okay. What
Yeah,
happens
there's-
in the middle?
Well, if you put one, let's see,
Here.
you put it there. You also have 4 ways that are the same.
So it looks like we have to divide by 4.
Okay.
So that would be 4 ways to. There's 4 ways to put it in.
Wow, there's only 4 ways to put a blueberry into a waffle like this if we count the ways by rotation
Yeah.
and they're the same. Is there any, can you think of any geometric interpretation of that here?
Well,
How do we go from 16 to 4?
we divided by 4. Oh,
Yeah?
you could.
Because it's only these 3 squares plus this square that you can put it into without repeating.
Okay. So one way we could look at it is these 3 squares plus that square. Is there any other way to look at it?
Well, if we're dividing by 4, well, if we have this outside layer of squares, and then we can just take that off, and we're left with a 2 by 2 square on the inside.
That's true. Yeah?
Do you remember?
You see any other way to look at this besides 1, 2, 3, and 1 like that? That gives you the 4 squares? I'm looking for something that's nice and symmetric.
Wow. This interior square, it's all the rotations of this one.
Right. Yep, that's true.
And then the corners are all the rotations of this one.
Yep.
So what can we make with those that could be symmetric?
Well, we could just make like an X.
Actually, it's this square here, because this edge is the same as that edge.
Ah, that's interesting. We can we can always, no matter where we put a blueberry in this waffle, we can always rotate it so that it's up in this upper left-hand corner square. Okay.
That's interesting.
And each piece has 4 pairs that go with it. 1, 2, 3, 4. And then we're back where we started.
Yeah, we can rotate.
So there's our 4. We can always rotate our starting 1 to this upper corner.
Cool.
Okay? You ready for
Yeah.
the next one?
Yep.
Yeah.